Hi, good day. My name is William T. Dongo. I'm here today to give you a lecture about climate control and refrigeration technology, fundamentals of air conditioning and refrigeration. This part of this lecture will be about on the lesson 6, which is the last lesson that I gave present to the YouTube. It's about basic air conditioning and refrigeration services. In here we'll be talking about pressure measuring and leak check. Under there cover the safety, pressure measuring, leak inspection, type of leak testing, and then we're gonna go evacuation and then charging. Okay? First thing I'll discuss is about safety. Safety, always wear protective eyes goggles when transferring refrigerant. When working with a pressurized cylinder, be careful not to drop it. Always keep safety cap on when moving cylinder. Be sure cylinder is strapped to cart or walls. Nitrogen cylinder must have a pressure regulator when used to charge system. There is too much pressure in cylinder to be connected to system, approximately 2100 to 2700 psi. If a leak develop and refrigerant or nitrogen is escaping, best thing is to stand back. Look for valve to shut off. Do not try to stop it with your hand. If careless and get refrigerant on your skin, it can cause frostbite. If careless and goes into your eyes, could cause blindness. Do not attempt to add refrigerant to eyesight. Okay? Eyesight pressure may be higher than the pressure in the cylinder. Could cause cylinder to rupture due to explosive pressure if using disposable cylinder. That means when system is operating, refrigerants will only be added to the suction side. Okay. Now we're gonna be talking about pressure measurement. The tools that we need to use for measuring the pressure inside the system. It is necessary to know what is going on inside the system. This is mainly determined by pressure measurement. Okay? Pressure gauge set. Okay, we got the pressure gauge set diagram or pictures is right here. Okay, I got it right here, in which we got two gauges, the high side gauge and the low side, and then we got a manifold which you got three openings, one for the low side and the high side, and then the middle is the one we connected to the hose that goes to the vacuum pump or to the cylinder, and then you got two valves on the other side, the high side valve and the low side valves, so you can put in or remove refrigerant inside the system. Okay? Pressure gauge, just the picture I showed you. High pressure gauge. High pressure gauge measure discharge pressure in cylinder from 0 to 500 on outer scale and temperature on the inner scale. Usually color coded red. Attached to manifold, service hose will usually be red. Compound gauges. Compound gauges measure suction pressure in system from 30 inches of vacuum to 120 psig on the outer scale and temperatures on the inner scale. Usually color code blue. Attached to a manifold, and then service hose will usually be in color blue. And then Service manifold. Service manifold, both high pressure and suction gates are attached to it. As service valves. It's like the one I told you, the one on the side. You got a high service valve there. Service hose is usually white or yellow. Hose is attached to center of manifold to allow refrigerant in or out of the system. And then we had a service valve. Service valve is attached to the manifold. By opening and closing refrigerant valves on gates manifold, we can obtain different refrigerant flow patterns. When both valves are closed, refrigerant hose is closed. Both gauges will read pressure in the system. When suction valve open and high pressure valve closed, refrigerant is allowed to pass through low side of manifold into the system. Used when refrigerant or oil is added to the system. Number 2, pressure gauge set. Now we talk about service valve, in which I'm gonna continue. When both valves are open, okay, center ports cap, used to allow refrigerant to pass from high side to low side, called cross bleeding. Okay, also used when evacuating the system. When suction valves close, high pressure valve open. Used when removing refrigerant from the system, usually in liquid form when the compressor is running. Already got that? That's the description of the manifold on how they should be operated. And now we're going to talk about the leak detection. This one right here. Leak inspection. Okay? Leak inspection. Be sure there is sufficient pressure in system before checking for leaks. Install manifold gauges, and then you check all areas with leak detector. Check all refrigerant lines and connectors. Check evaporators. Check condenser, and then you check the compressor. Okay. Then 4 types of leak detectors. We got the soap sud bubble, halide torch, electronic leak detector, ultraviolet, and then nitrogen can be installed in system to help find leaks. Okay. Pressure cannot exceed system leak pressure. After installed a system or after replacement of a component, check it again for leaks. This means if you check for leak, you can put the nitrogen, and then you can use the soap bubble to find for the leaks. The soap air bubble, soap and bubble type leak detector. And then evacuation. We're going to talk about evacuation. This one. Evacuation is that refrigerant systems are designed to operate with only refrigerant and oil circulating inside them. That means you're not supposed to be having any dirt inside the system, air or something, or extra any other type of air inside the system, because air is non-condensable. Okay? Refrigeration systems are designed to operate with only refrigerant and oil circulating inside them. When systems are assembled or services, air enters the system. Evacuation should be done anytime a system or part of the system has been opened. Evacuation pulls this air out of the system. Evacuation also pulls any impurities out of the system. And then by creating a vacuum, the water vapor in the system will turn to vapor and will be pulled out. Okay? Remember, if there's air inside or something or any type of gas, it will be pulled out by vacuuming the system. Theory of evacuation. Okay? Pulling a vacuum means to lower pressure in a system below atmospheric pressure. Inches of mercury, that's inch Hg. And then mm period HQ, that's a millimeter of mercury. And then 1000 microns is equals to 1 mm HQ. To measure micron, it is necessary to use electronic equipment. Atmospheric pressure is 14.696, that's 29.92 inches of mercury at sea level. PSI at 70 degrees Fahrenheit. Atmosphere will support a column of mercury, 29.92, in I, 760 mm, that is 760,000 microns. And then we reference to the next pages right here, in which I got this diagram here. I mean a table. Okay, this is the table that I have. Okay, in here we got the PSIG, PSIA, equivalent to inches of mercury, to the millimeter of mercury, and then you got the microns. And then you got saturation point of water boiling. Okay. And then we'll be talking about vacuum pumps. Vacuum pumps must be capable of pumping a very low vacuum. Most use rotary compressor. Two types of rotary compressor. We got the single stage and the two stage. Will pull the lowest vacuum, capable of reducing the pressure in a leak from system down to 0.1 micron. Most manufacturers require a vacuum of 200 microns. Okay. There may be few that requires as low as 50 microns. And then we gotta talk about the deep vacuum methods. Deep vacuum methods involves reducing the pressure vacuum in the system to 500 to 200 microns. When vacuum reaches the desired level, valve is turned off. If pressure rises, then stop. There is water vapor in the system. Continue evacuation until between 500 to 200 microns is reached again. If pressure rises and continue to rise without stopping, there is a leak in the system. Repair the leaks and then evacuate it again. It makes sense? If there's a leak, then you stop, you fix the leak, and then vacuum it again. Okay? This process will take some time. Many technicians let pump continue overnight or all day. This is the best way to do a good job. Care must be taken when allowing vacuum pump to operate overnight. If power fails, oil will be pulled from the pump. If pump restarts, pump may lock up. This can be prevented if solenoid valve is used. Wire solenoid valve coil in parallel with the vacuum pump motor. If power fails or someone disconnect its vacuum, it will not be lost. And then we talk about, now we're gonna have service valve. System using Schrader valve. At the gates port will take much longer to evacuate. These valves are easy to access, similar to valve stem core on tires. Can be replaced if leaking. To leak check these valves, gauge manifold gates must be removed. Special tools available to replace these valve pores without discharging the system. System using king valves. Okay. System using king's valves must be manually opened to evacuate or charge the system. Allow technician to seal off parts of the system. Some compressor may be replaced without discharging the entire system. You put this king valve, you can just close the valve and isolate the system, and then you can remove the compressor. Two-way valves, very common. When stem is turned to the pull inward position from seated, the refrigerant flow is shut off in system. When stem is turned to the pull outward position, that's back seat, it should off the charging, discharging or gates operating. Mid seat, that means all parts are open. System can be charged, evacuated or pressure tested. And then the next one we'll be talking about will be charging. Charging. The purpose of charging is charging a system refers to adding refrigerant to the system. The correct charge amount and type must be added to system. This is not always easy to accomplish. Refrigerant may be added in liquid or be performed. Proper amount may be added by using one of the following methods: by weighing refrigerant, by measuring, using operating pressure charts, that's the pressure temperature charts, temperature. Okay, now we're going to talk about low side vapor. The method of charging by low side vapor. This is a low side vapor method. That means accomplished by allowing vapor to enter into the low side of the refrigeration side. When system is not operating, vapor can be added to low or high side. After new installation and evacuation is done, vacuum in system. If system is out of refrigerant after deep evacuation is performed. When system is operating, refrigerant must be added to low side only. High side of system is used under more pressure than the pressure in the refrigerant cylinder. Okay, and then low side will have low pressure than the refrigerant container. Therefore, vapor will flow from high pressure area refrigerant container to low pressure area to the low side of the system. If pressure in the refrigerant container becomes lower pressure than the low side, it must be heated. That means you heat the cylinder. Never use concentrated heat from the torch. Use gentle heat. That means warm tub of water is safest. Refrigerant where heated rises in the Pressure, water temperature in tub should not be exceed about 90 degrees Fahrenheit. Pressure of refrigerant when heated will again be higher than the low side, or charging can take place. Now we're going to talk about charging on the I side, liquid method. Okay, normally accomplished in the liquid line. Remember, this is I side liquid charging. The normally accomplished in the liquid line, high side. System that is out of refrigerant can be charged with liquid into the liquid line after evacuation. If system is in vacuum, you can allow refrigerant to enter system until it nearly stops. Liquid will enter system and move towards the evaporator and condenser. When pressure is started, refrigerant is equally divided between the evaporator and the condenser, and there is no chance of compressor flooding. This method is very good when a large amount of refrigerant is needed. Much quicker than vapor charging. Liquid refrigerant charging into the suction line is not recommended. This can cause liquid refrigerant to enter the compressor. Liquid are not compressible and then results in the compressor damages. Be careful not to overcharge the system. Okay, the next method we're going to use is just by weighing the refrigerant. Weighing the refrigerant method is when a measured amount of refrigerant must be charged into the system, it must be measured in three ways. Weight with scale, measured with a graduated cylinder, using a operating pressure charge. Package refrigeration and air conditioning, EVA recommended charge will be printed on the nameplate. This charge must be added to the system from a deep vacuum only. That means you vacuum it and then you check how much is the amount of refrigerant supposed to be in the system. That's mean the weight, and then you charge it by weight method. And then you got the refrigerant scale must be accurate when using this type of charging. That is pounds and ounces. As refrigerant runs into the system, cylinder weight decreases. Dial type may be difficult to calculate exact amount of refrigerant put in. Electronic scale. We can use an electronic scales, charging scale that is more expensive than the dial type. Very accurate. This scale can be adjusted to 0 with a pull drum. As refrigerant leaves the cylinder, the scale gives the exact amount of refrigerant entering the system. And then some electronic scale can be programmed for the correct amount of refrigerant charge. A microprocessor controls a solenoid which stops the flow of refrigerant when the program weight has been used. And then you have the graduated cylinder method. Cylinder as a visible column of liquid refrigerant. Use pressure gauge at the top of a cylinder to determine the temperature of the refrigerant. The temperature is dialed. On graduated cylinder, the amount of liquid to be installed into the system must be calculated. Advantage is you can see refrigerant as it drops. Most graduated cylinders have heated at the bottom. This keeps refrigerant temperature from dropping as vapor is removed from cylinder. Be sure graduated cylinder is large enough for system being worked on. It is difficult to use cylinder twice and get an accurate method. Never mix, remember this, never mix refrigerant. Okay? And now the next one is charging using operating pressure charge. That means you got a pressure and a temperature, and then this is the method that I usually use. I can get my pressure charge from the dealer, and then look at the gauge. As the gauge give the pressure, and then it will have an equivalent temperature to the refrigeration inside the system. Using operating pressure chart. Some manual will give the operating pressure that can be used for determining the correct charge. Common called charging chart. Use your gauge reading for a comparison. Check manufacturer's specification. Okay? That means you can go to the dealer and ask for a copy. It's a small card that they call it pressure temperature charts. And then you always keep it on your wallet as a technician, so that when you charge by that method, you can get a references of the temperature and pressure relationship inside the system. Okay, that's all I got for this lecture. And then this is lesson number 6. And then this is the last section of the fundamentals of air conditioning and refrigeration. Okay. I thanks everybody if you watch my video, and then I recommend that you can go tell your buddies to watch it to get the general idea. I know it's not too much a pictorial, but you can go to the other YouTube that can explain, that you can get more idea of what I've been talking about. And then the next subject that I'll be giving a lecture about might be probably 6 lessons too. Is about basic electricity and electronics for heating, ventilating, air conditioning, and refrigeration system. So I'll see you there. Thank you very much. Enjoy. Thank you. Bye.